All right, good morning. This Monday, dreary, rainy day to the 8 period compacted math. Today we're finally starting something new in a sense because it's basically we've been talking about the word quadratics a lot in the last unit when we were doing all factoring, but we're finally at the point that we're going to learn how to not only solve them by factoring, but we're actually going to graph these quadratics. So let's start off with some basic things about a quadratic function. So you can see here the format is ax squared plus bx equals c, which we've seen many times when we've been factoring our trinomials. In this section, however, we're going to just focus on some easier graphing where there's not going to be a bx term. So it'll just be ax squared sometimes, and then sometimes we'll add a c. And we're basically going to look and kind of explore what happens when the a changes to positive or negative, or a fraction, or if it's 2 compared to like 8, and also what the c value does. Let's kind of look at some of the basics of a quadratic function. A lot of these terms we've used, and some of them we haven't. The biggest term that we've used already is a parabola. So parabola is a fun word to say, but it also describes the shape of a quadratic function, and it's basically that U shape is called a parabola. So again, when you have you could have a parabola facing upwards. That one's facing upwards. You could have a parabola facing downwards. So then the lowest or the highest point of your vertex, of your parabola, is actually called your vertex. So I'll do it here. So I'll underline just a little color coding here. This is pink. And so a vertex here, I'll draw the vertex for this one and this one here. Maybe if you're writing this in here, this is actually called, when we get to later sections, this is when the vertex is at the bottom of an upward facing parabola. This is called your minimum. And then when it's at the top of a downward facing parabola, this is called your maximum. Okay. So the line that passes through the vertex and divides the parabola in two symmetric parts is called the axis of symmetry, or I'm just going to usually call it the line of symmetry. Okay, so if you look back up here, right, and if you think about some things that are symmetric compared to things that aren't symmetric, like if I sketched, this is something that is symmetric. I'm trying to think. Yeah. A circle, for example, if I drew that perfectly, and drew a line through it, this side of the circle is the same as this one. However, if I drew like a weird looking shape like this, and drew a line through it here, this is not symmetric. So basically, all our parabolas are symmetric. So there's your line of symmetry. So I'll do that here so these are line of symmetry or your axis of symmetry. I'll do it in green. So this is it here. It kind of cuts right through the vertex like that and like that. So line of symmetry is huge when it comes to graphing quadratics. Because as soon as you get a coordinate on one side of the line, like say for example, this is the point, I don't know, we'll call it 0, comma 5, right? And if we knew this was like at 2, right? So say this is a little bit hard to explain a little bit without the actual numbers. So this was at 2. And we're going 0, comma 5. So now we know that this is 3 away from the line. So then I could just go backwards, 1, 2, 3. That doesn't work out with the numbers because then 1, 2, 3 backwards would be -1. Let's say this was 0, comma 10, right? And so it was, well, you'll see when we start doing it. Again, the numbers don't just work out, but again, the line of symmetry is really, really important because it basically cuts your graphing time in half, because if you once you know your line of symmetry and your vertex, and if it's minimum or maximum, it gives you a lot of hints, because if it's a minimum, you know that it's going to be pointing up. If it's a maximum, you know it's going to be pointing down. And so say you graph a coordinate, right, on one side of the line of the symmetry, then you know automatically there's another point on the other side of the line of symmetry that's perfectly symmetric. So again, just to recap the intro here, parabola is your U shape. Vertex is the minimum or maximum at the very top or bottom of your parabola. And then the really important line of symmetry, which we'll learn in 10.2 how to figure more out about that. But that line of symmetry is really, really crucial when we're graphing these quadratic parabolas. Okay, so let's turn the page here and actually start some of these examples. So this is 10.1, and again, notice we're just graphing ax squared plus c. Okay, so again, ax squared plus c. There's no bx terms, so that makes everything a little bit simpler and kind of a good intro. So down here at the bottom, I don't know if you remember back when we were doing linear functions, we had what's called the parent function. In linear world, the parent function was, so in linear world, you had a linear parent function. Maybe you remember it was y equals x. It was really, really basic. It was just, this is your x, this is your y, and it started at 0. I had an up 1 over 1 like this, and it basically just was super basic, right? That was your basic linear parent function. Well, in quadratic functions, there's also a basic parent function, and it's basically this one right here, y equals x squared. So let's kind of look at some of the properties of that as our first quadratic that we look at. The line that passes through the vertex divides the line of parabola into two symmetric parts called the like we talked about. I'm going to keep calling it line of symmetry. Okay. The axis of the line of symmetry for the y equals x squared. So if you look, where does this cross? It's right here. So I'll do the line of symmetry, I guess. And well, this is my vertex. Try to keep the colors the same. And then my line of symmetry was green here. So basically, the line of symmetry is the y-axis, or you could even write the equation x equals 0. But for all of these, you'll notice that our line of symmetry for anything that's ax squared plus c, your line of symmetry is always going to be this y-axis. It's not till the next section where the parabola will shift left and right, having different lines of symmetry. All right, so the lowest or highest point on the parabola is called, like we already said, it's the vertex. And the vertex of the graph y equals x squared is, of course, right here in pink. So you'd write that coordinate as 0, 0. But again, just to kind of show you a little bit more of this, so if you kind of make a function table, which is what we're pretty much doing, right? So if you go x and y, we put here, and we know it's y equals x squared. So just some basic stuff here. So when you're graphing these, right, you just put 0. And 0 squared, if I plug that in, is just 0. Now I can do some really other easy ones. So, because this is my line of symmetry, if I do 1 over here, I'll also know -1 here. So if I put in x equals 1 here, 1 squared is 1. So the same thing here. I don't even have to do it, even though it's simple. This is also going to be 1. So it's 1, 1, dot, -1, 1 here. Say I wanted to, just this graph doesn't show much more, but say I did 2. 2 squared is 4. So -2 is also 4. So I go 2, 4. -2, 4. Okay? So as you can see, that's some of the basics. And if I wanted to do one more, say I did -3. -3 squared is 9. So I know up here +3 would also be 9. And again, this graph doesn't go that high. But again, some of the basics. All right, so let's continue here for the first example. I'm going to start a new video so I can keep these going on YouTube. So this is the end of part 1.